Hi everybody. So the purpose of this video is to go over derivatives that require more than one rule and also to give us a little more practice in the chain rule. So anytime you have a derivative that involves more than one rule, it can sometimes be tricky figuring out which thing to start with. So I'm going to show you a few examples here where I take the derivative and I'm going to use a process that I call punting. Basically, it's if you come to a derivative that requires another rule, we're going to kick it down the road and do it a little bit later. You'll see what that looks like when I do it. So in this first example, you have e to the 2x times cosine of x squared. So you can see that e to the 2x has 2x inside of an e to the x, so that would require chain rule. Cosine of x squared has an x squared inside of a cosine, that also would require chain rule. But there's a product going on in the problem as well, so that there should be a product rule. So the question is, where do I start with this? Because I have multiple rules that are going on. So whenever you're trying to take a derivative, you always start with a rule that involves the entire problem. So if I look at this, the chain rule, sure, it applies to e to the 2x independently, and the cosine of x squared independently, but the product rule would involve the entire problem because it is a big product. So what I'm going to do is start with the product rule. Now, product rule, first function times derivative of the second plus second function times the derivative of the first. So when I'm doing that, I want to make sure I finish the product rule properly before I turn my attention to the chain rules that are inside of it. So this is where my process of punting comes in. All right, so here I go. Product rule says take the first function, e to the 2x, and multiply it by the derivative of the second function. Now that would require the chain rule. I don't want to deal with it right now. I want to finish my product rule. So I'm going to simply say I need to take the derivative of cosine of x squared later. Now I can finish my product rule. Plus the second function, cosine of x squared, times the derivative of the first. And again, I'm going to punt on that. Like that. Now I can focus on the derivatives that I haven't done. This part and this part are set in stone. So we're just going to be bringing those down as we work. So I'm going to turn to the cosine of x squared now. That's the chain rule. So I have an outside function, which is cosine of x, and an inside function, which is x squared. I'm going to take the derivative of both of those. Derivative of cosine is negative sine. The derivative of x squared is 2x. And then the inside function, that's g of x, gets plugged into f prime. That's the derivative of the outside function. And the whole thing gets multiplied by g prime, which is the derivative of that inside function. So this is now going to replace this because that's what it is. And that e to the 2x that we had earlier gets brought down like that. So now when I focus on the second part, outside e to the x, inside 2x. My derivative of e to the x is still e to the x. My derivative of 2x is 2. Whoops. Where's my undo? Here it is. And then my g of x, my inside function, gets plugged into my outside function and gets multiplied by the derivative of what's inside. So then this part gets multiplied by the cosine of x squared that was sitting above. So if I wanted to write this in a final simplified way, I could simply write everything in sort of a proper order, although it's not required. And that would be the derivative of the function above. So turn your attention to the blue example over here. This time we have a product rule on top. You can see sine times cosine. And on bottom we have a power rule, but the whole thing is a quotient. So again, we're going to start with a quotient rule. So quotient rule says low d high, which is going to require another rule, so I don't want to do it right now. I'm going to punt. Minus high d low. Now, sometimes if you don't feel like punting, you know you can do the derivative really quickly. you can go ahead and do it. Like, I know the derivative of 3x cubed is 9x squared. So I'm not going to punt. I don't need to. All over. Low, low. So then all I have to focus on is the derivative of sine times cosine, which is product rule. So product rule says first times the derivative of the second plus second times the derivative of the first. So this yellow part here, it replaces the thing that it circled, and then everything else in the derivative was set. And I might want to simplify that. So let's see. And you could either make an argument for distributing this, or I'll go ahead and distribute everything. This says sine x, I promise. Now I look at this and I could do some simplification with like the polynomial stuff, because every term has like stuff that can be knocked out. So I may go ahead and do that. It'll make it look prettier. So let's see. Again, this simplification is not required. It's just sometimes easier to make it match answers that you have. I'm basically pulling out a 3x cubed out of everything. So it has to be 3x squared, right? Let me go back and fix that. I'm pulling about 3x squared out of everything on top and bottom because those all have a common factor. So I end up with this. Oops. And that would be as simplified as I think I'd want to go. All right, on the next screen, I've given you two problems here to work on, and I'm going to ask you basically to pause the video and work on the red problem, and when you're done, unpause it, and the work for that derivative will appear, and then do the same thing with the yellow problem. Now, before we get started, I just want to remind you that when you have sine squared of x or tangent squared of 3x, that means the same thing as that. All right, so pause the video, try that derivative, and see how you do. All right, so we should start with the product rule. So this is what the work for the product rule looks like, and I punted on the derivative of the sine of x squared. And so in the next step, I'm going to do that chain rule thing that's required for sine of x squared. And there's that work for the chain rule. Outside is x squared, inside is sine of x. And so now I'm going to put it all together. And this is what that derivative would look like. All right, now try the yellow function. Now be careful on this one because the multiple rules you're using here are chain rule and chain rule, basically. You have it, again, I'll write it the other way so you can see what it looks like. So you see I have an x squared that's outside of a tangent of x, that's outside of a 3x. So when you use the chain rule, your first outside function will just be x squared and your inside function will be everything else. So give that a try. So this is what the first level of the chain rule looks like, where the outside function is x squared and the inside function is tangent of 3x. And so now I need to focus on doing this derivative because this is now set in stone. And so this is what that would look like. So if I wanted to write the simplified form of it, it would look like this. There you go.